Well, in this class, I'm going to discuss about 4 different mechanisms which are included in Cambridge AS level syllabus. These 4 different mechanisms are free radical substitution, electrophilic addition, nucleophilic substitution, and nucleophilic addition reaction. Let me first start with free radical substitution reactions, which will be performed by alkane. In this type of mechanism, we will have 3 different steps, that is initiation, propagation, and termination. First, to initiate the reaction, we have to use the ultraviolet light. Without the presence of ultraviolet light, this reaction will not happen. As we can see in the figure, ultraviolet light will make the bond fission. Here we will see homolytic bond fission. And by this type of bond fission, both the chlorine atom will get an electron. And these unpaired electrons are very highly reactive, so they can initiate the reaction. Next step is propagation. Well, by initiation reaction, we will see so many chlorine free radicals inside the reacting vessels. Well, then propagation step. In propagation step, the free radical will attack the methane molecule and will take an hydrogen from there. We'll get HCl and CH3 as free radical, that means methyl free radical. In the next step of propagation, this methyl free radical is also very highly reactive as it has an unpaired electron. So it will attack the chlorine molecule and it will take one chlorine atom. We have to use this type of curly arrows, which we can see in the figure, and we will see chloromethane is formed by this process. Okay. The next step of this free radical substitution is the last step, that is called termination step. In termination step, all the free radicals will join together. There are 3 different free radicals available in the reacting vessel. One is chlorine free radical, methyl free radical. They will join together to form chloromethane. Then chlorine, 2 chlorine free radical will join to form chlorine molecule again. And in termination step 3, 2 methyl free radical will join together to form ethane. The summary of this reaction is shown in this slide. Okay, I hope students you have understood free radical substitution mechanism. Our next mechanism will be electrophilic addition, and that electrophilic addition reaction will be performed by alkenes. First, we need to know what are electrophiles. Well, electrophiles are those species which has a deficiency of electron. So as it has deficiency of electron, so it will attack the species which has more electron. That means it loves to attack the species, as I have already mentioned, which have more electrons. So these electrophiles are also called electron loving species, and electrophiles will be fully positive charge or partially positive charge. Okay, so these electrophiles, now the question is why the electrophile will attack alkene. We know that alkene has carbon-carbon double bond, and due to the presence of double bond, alkene is a very high electron density molecule. So electrophile will attack the alkenes and will perform electrophilic addition reaction. Okay, let me show the next slide. Here we can see ethene molecule. here carbon-carbon double bond present, as I have already mentioned, that this is a very high electron density region. So electrophile will love to attack here. Now, this is a polar molecule AB. Here B is more electronegative, so both the shared electron which form the covalent bond between A and B will be shifted towards B. So as B is more electronegative, so B will be partially negatively charged, which is shown by delta minus, and as a result, A will be partially positively charged. So A can be considered as electrophile. So it loves to attack these pi bonded electrons. So this electrophile will attack these double bonds as it has pi electrons, which is very high electron density region. We have to show the arrow, curly arrows in this way based on the movement of the electron. We will see a species will form after this electrophile will attack the double bond. A does not have any electron, so both the pi electrons, there are 2 pi electrons available here in alkene molecule, both the electrons will be involved to make a bond with A. As a result, one of the carbon atom will be partially positive charged, as both the pi electrons are involved to make a bond with A. So one carbon will have a deficiency of electron. The next step, and this species which is formed in the second step of this mechanism is called carbocation, forming C+, is called carbocation. This carbocation has a deficiency of electron. This carbon has a deficiency of electron. So, and on the other hand, B has a pair of electron, as this species is formed by splitting this molecule. So B is will be negatively charged, which has a lone pair of electron, and here C+ has a deficiency of electron. So B, now the C+ can attack B. In the next step, we will see that B will make a bond with C+. There is a mistake in the figure. Here the direction of the arrow will be just opposite. It should be towards C+ from B-. So after the mechanism, in the last step of this mechanism, we will see an addition product is formed. That is why it is called electrophilic addition reaction. Here C+ has deficiency of electron and B- has available electron. So when they will make a bond, then there won't have any deficiency of electron. We will get a neutral compound at the end of the mechanism. I hope you have understood electrophilic addition mechanism. Well, our next mechanism will be nucleophilic substitution reaction, which will be performed by halogenoalkanes. Halogenoalkanes will have an halo atom with the carbon. We know that halogens are very highly electronegative. They are group 7 elements. So obviously they will pull the electron cloud towards it, and as a result it will be partially negatively charged. The halogen will be partially negatively charged. On the other hand, carbon will be partially positively charged. All the halogenoalkanes will form this type of partial positive and partially negative charge. So when carbon is partially positive charge, then nucleophile will tend to attack this C+. Nucleophiles are those species which has a lone pair of electron, and it tend to give that pair of electron to another species. So that is why it loves to choose this C+, because this C+ has deficiency of electron and nucleophiles has available has more electrons. We can give some examples of nucleophiles like ammonia, cyanide ion, hydroxide ion. All these species you can see a lone pair of electron is available. So these are called nucleophile because as they can donate this pair of electrons. Well, nucleophilic substitution reactions are two, SN1 and SN2. Today I'm not going to explain SN1, SN2. I'm just showing the general mechanism of nucleophilic substitution. Here is halogenoalkane where C carbon will be partially positive charged, and when a nucleophile will come closer, then this nucleophile loves to attack this C, and at the same time, as halogen is more electronegative, X denotes halogen. It can be fluorine, chlorine, bromine, iodine, any haloatom. So it will pull both the bonded electron as it is more electronegative. We have to use the Carli arrows by this way. So you can see that a nucleophile will replace these haloatoms from here. As it is more electronegative, so it will be removed after taking that bonded electrons. It will be removed from the molecule, and nucleophile can substitute the haloatoms. I'm not going to explain SN1 and SN2 here. Our next mechanism will be nucleophilic addition reaction. Well, I'm gonna change the slide. Nucleophilic addition reaction will be performed by carbonyl compounds. Carbonyl compounds, that means the organic compounds which contain CO group. Both aldehyde and ketones are included in carbonyl compound group. In all carbonyl compound contain carbon oxygen double bond, as pi bond is present here, so it will tend to be very reactive in the reaction, as we know that pi bonds are very weak. Oxygen is much more electronegative than carbon. So oxygen will be partially negatively charged and carbon will be partially positively charged. So this carbon can be attacked by nucleophile. Let's see the mechanism in the next slide. Well, this is a carbonyl compound. Oxygen is more electronegative, so both the pi bonded electrons will be shifted to oxygen, and we have to show it using these Carli arrows. We must have to use these Carli arrows in the reaction mechanism. And carbon will be partially positive charged when it is bonded with oxygen, so this carbon will be attacked by nucleophile like cyanide ion. It has a lone pair of electrons, so it is a nucleophile. So this C plus will be attacked by this carbonyl, by this nucleophile cyanide, and we will see a bond is formed between carbon and cyanide group. Oxygen is still negatively charged as both the pi electrons already shifted to oxygen. So this oxygen now will be attacked by electrophile, which is available in an acid like hydrogen cyanide. We'll use hydrogen cyanide in this reaction. So H plus will attack this oxygen atom and will make a bond, and by making this bond the ion will be removed as oxygen has available more electrons and hydrogen has deficiency of electron. So they can H plus will be compensated by the lone pair of electrons of oxygen which was available here. By this way we will get this molecule. The name of this molecule is hydroxynitrile molecule. Well guys, today I have explained 4 different mechanisms which are very important in Cambridge AS level exam, and you know that in all exam, in most of the exams, these mechanisms are very important because any of these mechanisms may come in the paper 2, or there are many questions in MCQ part comes from this different organic mechanisms. I hope you have understood, and this class will help you a lot. That's all for today. Thank you very much.